Now let's continue with the discussion of weight, mass, the other things at different places. So the first thing first, the mass must be the same at all situations because it's got something to do with the amount of matter in it. And then for an object at rest, say on the Earth, the weight is 600 Newton. When it's free falling, the Earth is still attracting it, so it's still 600. And so is the case for an ascending lift and a lift accelerating down or decelerating up is still the same. However, the normal reaction, the root, will be different. So when the lift is at rest, the normal reaction is 600. So the net force on it is 0, and the body can be at rest. However, when the body is free falling, so the only force acting on it is the gravity, so there should be no normal reaction acting on it. Otherwise, it is not free fall. And for a lift accelerating upward or decelerating downward, so the acceleration is upward, so there must be a net upward force. So the normal reaction acting up must be greater than the weight of the object of the body, so it's greater than 600. However, when the lift is accelerating downwards or decelerating up, the acceleration is down, so there must be a net downward force. So the normal reaction upward force must be smaller than the downward force, the weight. So it's smaller than 600 newtons. And then a sense of how heavy. So it's the sense of the normal reaction. So it's the sense of 600 newtons. However, when it is free fall, we don't feel any normal reaction, and we call this state weightlessness. Now, the term mentioned in the last video is useful. Is the apparent weight has gone 0. It's not the true weight of the force acting on the body. And next, when the lift is accelerating upward, so we feel the normal reaction as the weight. So the sense of weight is greater than 600 newtons, and the lift is, when it is decelerating, the sense of weight is smaller than 600 newton. So the reading of the weighing scale in the first case at rest is of course 600 newtons, and in the second case free falling, 0 newton, and in the third and fourth case must be the same. Okay, so there's some point to note. Now the first is that weightlessness happens when 0 or no, when no normal reaction is acting on you, or more precisely, the upward force acting on us is 0. While free falling, the only force on the body is just the weight. It's just the weight. It's just the weight, and no normal reaction acts on us, so we experience weightlessness. Okay. Now, weightlessness is the feeling only. Mass and weight is not 0. It is normal reaction, which is 0. So the next example, the C questions, okay, is left as an exercise. Let's take a